Okay, so here's my second video on factoring by grouping. Now, on our sheet we put down a couple things that were important, so I'll just reference them in case you don't have these notes. When should you remove a common factor from a quadratic? And the answer is always. If you see that all of the terms of a polynomial are divisible by the same thing, you should factor it out to the front every time that you see that. The three types of factoring that we've used so far are double bubble factoring, greatest common factor, and grouping. And grouping is what we're doing. We know to use factoring by grouping when there are four terms. It's super important. When there are four terms and the question says factor, you know that you're using factoring by grouping. There is no other method that you're going to learn to factor four terms. Now it's important to remember that factoring doesn't mean solving anything. Factoring just means rewriting it in an equivalent form that's either broken down or more useful. So I'm going to give you a couple of examples. If you need the steps, they're on the previous video, but I'm just going to go through them and say them out loud. I'm going to start with question number 23. Question number 23 has four terms, and the question instructions say factor. So I know that I'm using grouping. Grouping means that I'm grouping the first two, and I'm grouping the second two. What I'm doing is I'm trying to see, is there a GCF, or greatest common factor, for each of these brackets, each of these pairs of terms? What I see is in the first I have a 2 and a 5, right? 2 and 5 don't have any common factors. There's no number that can divide into 2 and 5. So what I'm going to do instead is I'm going to pull two x's, an x squared. I'm going to pull an x squared off of each one of these terms here, and I'm going to pull it out to the front. When I pull that x squared off, he comes to the outside of the parentheses, leaving me with 2x minus 5. Now you can distribute back in if you want to check to make sure that you get this. And that's a good way to check to see if you're right. Now I need the GCF of the second group. This sign right here being a negative, the first sign on the pair, that being a negative tells me that I'm going to factor out a negative. So what's a number that can go into 8 and 20? The answer is 4. But I'm going to factor out a negative 4 because that's what this sign here suggests that I do. When I factor out a negative 4, it's going to leave me with a 2x minus 5. If you don't believe me and you think it should be positive because this guy is, let's see what happens if we distribute back in. Negative 4 times 2x is negative 8x. And negative 4 times negative 5 is positive 20. Okay, so when I pulled out that negative, it switched the signs on the inside. I just do that distribution to make sure that I didn't make any mistakes. Now what I'm going to do is I'm going to take the outside stuff, which is these guys, they're outside the parentheses, and I'm going to combine them into their own set of parentheses, x squared and minus 4. Now the identical guys, these guys here, they should be identical every time you factor by grouping. They're going to get combined into one parentheses themselves. Now this is the end. If the question says factor, if it just says factor, this is likely the end. But you may notice, especially if you were in class today, that there's something special going on with this guy. With this binomial here, this is what we call a difference of two squares. X squared is a square, 4 is 2 squared, and this is a difference because difference means subtraction. So this can be broken down into, imagine square rooting this and square rooting this. You would get x and 2, and you get x and 2. Now, difference of two squares breaks down into what we call conjugates. You have a definition for this already in a previous lesson, so I'm not going to rewrite it. Suffice to say, this is a plus and this is a minus. Now I'm going to bring down the 2x minus 5, And I'm going to read the question, and the question tells me to solve for the roots. When it tells me to solve for the roots, that means I have to set it equal to 0. And I always like to say, because it said roots. In order to solve this, now that it's fully factored, I need to give myself a giant sort of T-chart here and say to myself, what if 2x minus 5 was equal to 0? What if x minus 2 was equal to 0? And what if x plus 2 was equal to 0? And solve for x. These two are easy. It's just the opposite sign. Negative 2 plus 2 would be 0. And this one's easy too. It's the opposite sign. This is going to be positive 2. On the right, I'm actually going to want to solve for x. So I'm going to want to plus 5 plus 5. I get 2x is equal to 5. Divide off the 2. And I get x is equal to 5 halves, which is equal to 2.5. So those are the roots of that equation. One more example to make a point to make your life a little simpler if you get a harder version of this. If you're feeling confident, you might want to pause right now and do this question yourself. Okay, if you're watching this, I'm going to assume it's because you got stuck at one point. Hopefully not. Hopefully you're just checking to make sure your answer's right. But I have 4 terms, and I'm going to group them like this. The first pair has a GCF of just x squared. There's no numbers that divide into 7 and 9. So when I pull out the x squared, I get 7x plus 9. On the right-hand side, you're probably saying to yourself, those numbers are gigantic. How do I know what to do? How do I know what to even check to see what factors in? I'm going to give you a tip. Remember up in this example, how we had the 2 parentheses, let me zoom up, and they were identical? That's always going to happen. So essentially what I'm saying is after you divide something out, after you pull something out to the front, you're going to get another 7x plus 9. So the question is, what times 7x would give me negative 1008? An easier way to check that is to use division. Negative 1008 divided by 7 is equal to 144. Well, negative 144. Okay? If you wanted to do the same thing, you would say, what distributed to here, so times 9, would give me this. Do the same division. Negative 1296 divided by 9 equals, what do you know? Negative 144. So that's a way to sort of figure out what your GCF is going to be if you can't see it. So what I'm saying is I'm going to pull out a negative 144. Now how did I know that it was supposed to be a negative 144? Because of that right there. You can check if you want, distribute this back in, do the multiplication in a calculator, and check to make sure that you get these, but I promise it's correct. Now what I do is I combine my outside stuff, x squared minus 144, and my inside stuff, 7x plus 9, and they want the roots, right? If you read the example, it says that it wants the roots. So that means I'm going to have to set equal to 0. I'm not done factoring. This guy is special. It's a difference of 2 squares again. So that means this is going to turn into square root of that, square root of that, x and 12, x and 12. So plus 12 and minus 12. If you don't believe me, multiply these. Use a box method, multiply these, and go ahead. You're going to find that you get this. I'm not actually going to do that. I factored this guy. He becomes this and this. And I bring down the 7x plus 9. Still all equal to 0. and I just have to solve for x. It's a big sort of weird t-chart. This is going to be negative 12. This is going to be positive 12. And here I'm actually going to solve. 7x plus 9 equals 0. Minus 9 on both sides. 7x is equal to negative 9. Divide by 7. Divide by 7. And I'm going to get that x is equal to negative 9 over 7. So that is the full example. Let's see if I can delete that. Yeah. So this is the full example for question number 45. If you have any trouble on the homework and this doesn't help, please contact me and let me know. And don't forget that Monday after school is the retake of the last exam. Good luck with homework. See you tomorrow.